Good afternoon, everyone. Again, this is Mr. Sadler. I apologize for being sick. I had a minor medical thing I have to take care of today. Luckily, I found out about it Thursday night at about 8 o'clock, so I can make this video for you. So, hope you enjoy again. Today is October the 26th, 2012. So once again, just like yesterday, please play along if I call on you. Please have some fun with this. This is one of my favorite lessons to do during the year. We start to talk about money. In fact, today's title is going to be compound interest. Okay, so we're going to begin to talk about money in this course. For the supply teacher, your job today is just to hit pause when the video asks you to hit pause, to encourage the class to ask questions, and if there are any clarifications or calculator issues you can deal with, please do so. Okay, so simply enough, we'll say that compound interest is when interest is earned on interest. So instead of just you earning interest initially, it's going to be earned again and again and again. This is one of the main applications of exponents. Exponents, just remember, repeated multiplication. So example 1 is going to say, I should pick a random person here for this, which is going to be Hannah. So we'll say Hannah W opens a bank account with a deposit of $500. She earns 4% each year. How much will she have after 6 years? Okay, this is a good typical question that we'll use in this unit. It involves money and savings and investments. We will find efficient ways to do this. We'll start this with the long way. Example 1 will be the long way to do this, and then the rest of the examples today will be more efficient ways. So we're just sort of going to make a chart. So after 1 year, what's going to happen is she's going to have $500, and it's going to go up by 4%. And we're going to multiply that by 1.04. So what they mean by why it's 1.04 is because the 1 is 100%, like that's the value that you originally had, and 4% interest on top of that. So that's just going to turn to be $520. So after 1 year, Hannah will have $520. After 2 years, okay, it's going to be, we're going to take this idea of compound interest. It's going to be 520 times 1.04. And I'll get my handy dandy calculator, which unfortunately isn't open yet. So we're going to say 520 times 1.04, which is going to be $540.80. Now this is the idea of compound interest. You have earned interest not only on the original $500, but you also earned it on the $20 that you earned secondly. If you'll notice, the difference, the amount that she earned here, the difference between the 540 and the 520 is $20.80, which is actually bigger than the $20 she earned in the first year. So she's earning more and more and more year after year after year. That's why this is called exponential growth, because as time goes on, you'll be able to see that we will earn more and more and more each year. So the third year we'll do the same thing, 540.8 times 1.04, which is going to be $562.43. Now please round to the nearest penny, in this case, which is 2 decimal places, and that's perfectly okay to do. That's the way banks do it as well for that. Now you can see how this could get a little tedious though. Okay, we're going to keep on going here, and actually I'm going to stop here and see if we can find a quicker way to do things. I'm going to pick on a random person, which is going to be Karina, who told me she's not going to be there, so we're going to pick on Hannah Cassidy, who's also not there. Jillian is who we're going to pick instead. Okay, so Jillian, can we see another way we can write this? Because this is starting to get complicated. Specifically, I'm looking at this line. Okay, is there another way I can write $520? Okay, well hopefully what you said was $520 we learned from the line above is the same as 500 times 1.04. Okay, excellent. Okay, so one other person, which is going to be Matthew Young. What's 500 times 1.04 times 1.04? What's another way I can write that? Okay, well hopefully you said 500 times 1.04 squared. Okay, now this we can very easily do in our calculator then now. So this is going to be 500 times 1.04 squared, which is $504.80. Now this is the nice thing about this. Okay, we're going to continue on with Caitlin. Caitlin, what's another way that I can write $540.80? Hopefully what you said was 500 times 1.04 squared. Times that by another 1.04 and you get 500 times 1.04 cubed. Oops, that should be cubed. Okay, so this is looking really good now. Instead of doing these repeated calculations, we can go right to the final answer. Okay, so Savannah, after 6 years, what's my equation going to be? Very good. That's 500 times 1.04 to the power 6. Okay. So we just repeated the interest, which was increasing by 4%. You multiplied it 6 times. And we'll do that in the calculator. If you don't know how to do this on the calculator, we'll do this as slowly as possible. And hopefully fit it on the screen. 1.04 to the power 6 equals times 500. And you get 630, oops, try again. Let's try again. $632.66. And we'll say, therefore, after 6 years, Anna will have $632.66. Okay, everyone take a second to make sure, and the supply teacher can probably hit pause here. Everyone take a second to make sure that you can get this number, because this is really, really important for our calculations. So to make sure you can do 500 times 1.04 to the power 6. If you can hit pause right now, supply teacher, I would greatly appreciate it. And hopefully we're back. From this, we can use a very powerful formula, which is going to be the formula for compound interest. And you will need to commit this to memory in the class. This will be the first equation we have to sort of commit to memory in this class. This is also called the Payne formula. Okay, it is the Payne formula for 2 reasons. One, because it spells pain, also because math is painful. A equals P 1 plus I to the power n. Okay, and all four of these variables have values. P stands for principal, which is your starting value. Okay, so this is the starting value. So in the above equation, that would be the $500. That's how much Hannah started with in her account. A equals the amount, which is the ending value. Okay, so in the above example, that would be the $632.66. I equals the interest rate and n equals time, which is normally the number of years, the number of compounding periods. Okay, and that's the Payne formula. We'll be using this one lots in the course. Now, this is an application of exponents, as we said. It's also an application of logarithms, which we talked about yesterday in class. You should be comfortable solving for every variable in here, P, A, I, and N. So what we will do is we'll work a few examples today, making sure that you can do all those things. I'm going to give you guys a second to copy that down. I'm going to stop this video now so it doesn't get too big, and then I'll start the next examples with the next video. Thank you.